So today it's about dividing polynomials. Like you might have thought that long division was fun. How about long dividing with variables? All right, so let's just make sure you remember how to long divide. If I said 7 goes into 217, I'm going to do this one with you. Please write it out and let me show you this process because it is not something that most of you are good at. And if you can't do it with this, how are you going to do it when we have x plus 2 and we're dividing into x squared plus 3x plus 4 or something like that? Okay, so you clearly need to know how to long divide before you long divide with polynomials. And this is on your test. This test is coming not tomorrow. Tomorrow's the review day, but Wednesday. So we're talking 2 days from now. You have a test on this that you're going to learn today. So pay attention really well to today. So 7 goes into 21. I think you all know it goes in there 3 times. 7 times 3 is 21. Let's put the 3 exactly right there. Now you go and you go 7 times the 3 makes 21. And then you draw a line like this. And then there was never any line here. I was just trying to draw attention to the 21. There is an opposite right there. You put that in even though there was never a negative. Notice there were no negatives until now. And I want you to think of this as the opposite of what we had. Because in polynomials, sometimes some of them are plus, sometimes they're minus, and we just do the opposite of them. All right, so then what's 21 and negative 21 make? Nothing. There's nothing left. So can I just be done? No, because there's a 7 still, so you bring that down. And then you start the process over again. And you say, does 7 go into 7? Yeah, how many times? Once. And then you go 1 times the 7 makes 7, and you do the opposite of that, and you draw the line, and see how there's a 0 at the end? That's called, anybody remember?
0.
It is 0, yes, but what I mean is it's called a something, and it's got a name, and it starts with an R. Remainder is correct. So there was a remainder of 0. All right, we're going to now just do the simplest one of them all. X goes into x squared plus 2x. That'd be about as simple as I could make a long divide with polynomials. Write this one out and then do it with me. Then you'll learn like where stuff goes, okay? First thing, we've got to say, how many times does this go in? Well, I just will give you this advice. Always start with an x. And then do you remember how we always multiplied this times this? Right? So when we go x times x is x squared, and we put it here. Then remember me saying that I didn't want you to call it subtract. I just wanted to call it opposite of, because I'm going to go put a negative right there. Because later, sometimes the problems have a negative number right there, and we need to do opposite and make it turn positive. It won't always be subtract, but it'll always be the opposite of. Okay, so now I put those together and I have nothing left. And same idea as last time. Can I just quit? No. What do I do to continue the problem? I bring this down, and then I say, now what goes up here? Okay, now what goes up there? Can you do it? Yes. 2. And I'm going to make it positive 2. You should always pick them to be positive or negative so that it doesn't look like x2 on the top. It's x plus 2. And then 2 gets multiplied out. Watch this. 2 times the x makes 2x. And that's why he picked 2 there. He was thinking ahead, and he was going, what should I put there so that it'll cancel this out? And you draw the line, and do you think I'm left with 4x? No, because you make it the opposite of whatever it is. And then there's a 0 remainder, and yay, it worked. But what was the point? It factored it. Do you get that this times this equals that? It's a tool for factoring. It's kind of like that 7 and 3 made 21, right? 7 times 31 makes 217. You factored it. So that's what long dividing is factoring. All right. let's try another one, except this time back to long division. 7 goes into 24. I just want to see if you know what to do with the remainder. Everybody give this one a shot. And in a moment, I'm going to ask you to compare with the kid next to you. For you guys, you'll just have to go diagonal. Okay. Tyler, you're going to turn and check out the people behind you. For you guys, it's the person straight across, very simple. On the end here, you two guys can compare. Would you please compare with JP? And then you three, 1, 2, 3, all compare with each other. Whatever this is, set it aside for a minute. I need your full attention on this. Okay. Long dividing 7 into 24. And in a second, we'll change it to polynomials. But if you can't do it with regular numbers first, how can you do it with polynomials? Try it. Check with the kid next to you. See if you know what the remainder is and what the answer is. And so, so we went 3 here, and this is 21. You drew a line. Opposite. So it's 3, remainder 3. Does that make sense to you? Okay. Now what does this mean? That means 7 times 3 doesn't make 24. But if you take 7 times 3 and add the remainder, then it gives you 24. See what I mean? 7 times 3 plus this guy. 7 times 3 is 21 plus the 3 makes the 24. Okay, so now let's see if you can get it with factoring. This is, again, a super simple one to start with. 4x squared plus x. Just factor the x out. Long divide way. You really need to try hard on this. If you do, you can master this one topic. I'm telling you, it's going to be on your test. If you don't know this, that would mean, yeah, you could still get an A on the test without knowing this, but you'd have to be perfect on everything else. That's unlikely. So, let's make sure you get this. What did I say to start with? I think some people have already forgotten. What did I say you should always start with? Say it if you know it. X. Always start with an X. Why? Because then when you multiply this times this, you'll be able to hopefully get something that matches up with that. All right. So when I take this out, I have x times x is x squared. And then I do the opposite thing. And then I have 3 x squareds left plus an x. Do you get how I needed to bring this down? All right, this one's really evil and it's getting really complicated. I apologize. It's not, this one's got a trick to it and you won't have to do it. So I'm gonna punt and say, yeah, we won't have any that hard. I'm sorry. We'll do another one. You will have one this hard. Okay, so your first thing you ask yourself is, what do I put here? And server said we should start with an x, so I guess I'll start with an x. No, it's not going to be that hard then. Then you go x times the x, and then see if you can do this. I'll pause again. Sorry for that really hard one there. This will hopefully get your confidence back again. What did you think you should do after you put the x here? You go multiply it out, put x squared here, then what?
Well, it's minus.
Yep, very good. So putting a negative.
0 minus 16.
Bringing this down. Okay, good.
And then 4 goes into 16 4 times.
All right. So I'm going to go plus 4 or minus 4.
I put minus 4.
You are correct. It's minus 4. So that when you go minus 4 times the x, I get negative 4x. What the heck is happening here? And minus 4 times the 4 makes negative 16. I make this the opposite and the opposite. And I get 4x, this 4x. All right, that got really weird. You know why it got really weird? Because there was a missing term. You guys will have to handle this if we give you one that that has a missing term. Do you get that these normally have like a plus 3x and then a number like minus 16? There was no regular x. There was an x squared, and it skipped over this one, and you had a number like this. So this one, I promise, will work out really nice. It won't have any missing terms. And when you put this into it, it'll work out perfectly. No weirdness. Now that you practice it a couple times, I think you'll appreciate how it works out really nice. Okay, so I hope you knew to start with an x, because I told you always start with an x, and the x goes times this and makes x squared. But you got to remember to also multiply it by that. And so then that's x times the 3 makes plus 3x. Draw the line, and I bet a lot of people screwed this up right here. The negative has to be on both parts. That negative goes to both things. Everything on this line has to become the opposite of what it was. And now I got negative x. And then I bring this down to negative 3. And that's setting me up for that last number. Eddie, what do you think goes right here?
Yeah, I didn't do it.
Okay, then let's think it through together. We got to put something there so that when we times it by x, it'll work out nice to go right underneath here.
2.
Okay, let's just try it once. If I put a 2 there, 2 times the x will make 2x, but the problem is it doesn't all cancel out. Do you get how I'm not going to have it all canceled if I put a 2 there? Because I'll have a negative x and a plus negative 1, exactly. But you see, you learned from sticking it in that, no, I probably want a 1 there. So now I get negative x, and you might be thinking, but then those aren't going to cancel. But remember, their signs will change in a second. And then this makes negative 3. And again, draw the line. Opposite, opposite. And then everything cancels. 0 and 0, and there's nothing left. No remainder. That means this times this equals that. This is a skill that is on the ACT test. It's not on every ACT test, but it's on their list of things that you have to know. Okay? And it's also on our next test. So there's 2 reasons to know it. Okay. Let's do one more. This is a little more complicated. X to the 3rd plus 2x plus 4. Oh, I missed a term. Sorry. I don't want to have any like gaps in there. And missing terms, those are the complicated ones I showed you before. This has an x to the 3rd, an x to the 2nd, a regular x, and the last number doesn't even have an x. Does anybody remember what it's called? Starts with a C. Constant, thank you. Now, we're going to divide that all by x plus 2. You'd seriously have to do something that big? Maybe. That's about as big as they would likely get, but don't get scared just because the problem is really long. It's really not that hard. It's just one little step at a time. You start with an x. But the problem you'll realize is that only gives you x squared. And that won't make an x to the 3rd get canceled. So guess we can't just use an x. You got to be ready to change that to something else. Like what? X squared is correct. Okay, everybody try. Just to get the first line here. Don't need you to finish it, just try to get the first line. I'll pause the video again for a second while you work on this. It's going to be this times this. This times this. Okay. J, multiply that out for me. X squared times the x. I'm going to pause this. All right, so you got the x squared times the x is x to the third, and that matches up real nice with the thing above it. And now how about x squared times the 2? Jay, you got this one? X squared times the 2.
2x squared.
Yep, 2x squared. Then we go through and do the opposite thing. Opposite, and that way everything canceled. Sweet, we're done. No, we're not. But do you get that we actually have to bring down 2 things? 4x plus 8 needs to come down. Why? Because if I put anything on the top right here, I'll have to multiply it by 2 things. You know, I'll have to multiply it by the x in the front and the 2 in the front. So I need 2 things underneath that. All right. Miss Thomas, can you take a best guess on what this number should be? Right there.
1.
Okay. If I put a 1 here, now I'm going to multiply it out. What's 1 times the x?
X.
Yep. And what's 1 times the 2?
2.
But it didn't perfectly cancel. So I bet you're looking back and saying, I should have picked a
4.
4. There it is. And is it a minus 4 or a plus 4? Think carefully. There's only pluses in the problem. Plus 4. So I'm going to multiply that out. 4x. 4 times 2 is 8. And if you're like, but I wanted him to cancel. That's what happens when I go through this. Minus, minus. 0 remainder. Cool. That times that makes that. I need honesty here. How many of you had x squared plus 4 before I ever said it? All right, that's less than half, so we're going to try another one like that. X to the third minus 5x squared plus 2x minus 10. All that gets divided by, I think, x minus 5. I said to start with x, but I also said to watch and see if this first term would cancel. If you just use an x, it won't work, so be smart. All right, x times that. Oh, that's not working, so I don't use x. Truckee, do you know what I use?
X squared.
Yep. And then that makes x to the third, but you also have to multiply it by that, so what's next?
It's either plus or minus 5.
It's minus 5x squared to start with. Then you go through, after you're finished, and make everything the opposite of what it is. Notice how one's plus and one's minus now. Because you do it, before you change the signs, you just multiply like normal. This times this, and this times that. And then you switch their signs. Okay, and now, oh my gosh, it's perfect. Everything canceled. Canceled, canceled. Can you please take it over from there? Somebody raise your hand and just tell me what to do. Please, sir.
After that, just put in a 2.
All right, so I'm putting up a 2.
You get
Let's bring these down to where it's easier to work with them. And you get 2 times the x. 2x. Keep going.
minus 10, and then flip it around to negative, so x plus 10.
Yep. Cancel, cancel, cancel. Nothing left. Cool. This looks a little weird because there's one sign missing. Can you clean it up?
Plus
That's a positive 2. So, x minus 5 times x squared plus 2. I'm going to write that all out. X minus 5 times x squared plus 2 is equal to this whole thing. Because these are factors. And now, by the way, what's the actual answers? Well, that is the factored. If all they want is factored, I'm done. Otherwise, if they want the other answers, x equals 5. And can you guys set that equal to 0 and solve it? X squared plus 2 equals 0. X squared equals negative 2. Square root. Absolute value of x. I root 2. I think this is going over some people's heads. But final answer would be, I'd get 2 answers. Once is x equals I root 2 and negative I root 2. So one person could argue plus and minus I root 2. My answers were 5 and plus or minus I root 2. All right, it got intense, I know. Well, I think we should get into some of the problems in the actual notes here. I want you to try this pink one. Now, they're not telling you what goes inside. I can tell you that the bigger one goes on the inside. It's like the bear goes in the den. Bears are big. And that's like a den. And the other reason I like to call it a den is this part is called the dividend. Goes in the den. And the x minus 5 goes out here, and that's called the divisor. I like to think of it as the divider. That's the thing that's dividing the other stuff. You're dividing by that. Okay, now I got to put an x on the top, but I hope you're smart enough to know it's not x. What is it actually? X squared. Now see if you can finish it. If you're stuck, raise your hand and say, help me. And I will help you. Happily. Going a little further with this one, and this times this is x to the third. This times this is minus 5x squared. Draw a line. Always do opposite, opposite. These two cancel each other out. And right here I saw more than one person messing that up. And it was 4x squared. Because positive 5x squared and minus 1x squared makes 4x squared. Then you bring this down And you get minus 26x. Catch up to me at least. Get to there. If you got stuck, get it to there. So Parker, can you tell me what's next?
Yeah.
Something goes at the top.
It's plus 4x.
Plus 4x. How did you pick that? Did you like try some stuff and it didn't work until you finally found it, or what?
No, because then if we multiply that by the x, it like cancels out the 4x squared.
You are right, sir. And the 4x times the negative 5?
It's it's negative 20x.
Yup.
But then it changes to plus 20x.
And we do the opposite thing. It becomes plus. Put these two together. What do you get?
Negative 6x.
Bring this down. Last term. Parker, you got it?
Yeah, it's negative 6.
It's negative 6. Negative 6 times the x, negative 6x. Negative 6 times the negative 5, positive 30. Draw a line. Opposite. And this becomes positive. This becomes negative. It all cancels. Sweet. That times that equals that. That's called factoring. Now, I don't know if we would have one this hard on the test. We might. I'm going to write out what our answer was. X minus 5 and x squared plus 4x minus 6. Is there any chance that we math teachers would be evil enough to make it so you have to factor this again?
Yes.
Yes, for sure. So I honestly don't know. I think it would have to be an R3 then. We might not make them this hard, but if we did, it would go like this. And then I'd be thinking to myself, how do I make a 6? That like 5 and a 1 makes it. Ooh, it's 5 and a 1. No, wait, 5 and a 1 doesn't make a 6. 6 and a 1 makes a 6. 6 times 1 makes 6. Thought for sure I had it with 5 and 1, but 5 times 1 isn't 6. It's got to be a positive and a negative. It has to be. But I'm afraid this doesn't factor any further. Can anybody else figure out how to factor it the rest of the way? Okay, I guess I was done. I thought this factored for sure, but I can't see a way that it factors. 3 times 2 makes 6. That can't make a 4x. So I guess it was done right there. Always look and see, though, if you can factor it one more time. Okay. Want to know what else you're going to get tested on besides long division that you just learned? Don't even have to do it, but can you just like see if you would know what to do with that minus? Can I just drop the parentheses on this kind? No. Is this the kind where you like distribute it like this? No. See lots of shaking heads. You're right. It's a minus problem. You don't distribute. So what do? If you can't drop the parentheses, it must be because there's something you got to do before you drop the parentheses, and that's who is thinking you got to distribute this. Raise your hand if you knew that that's what I was going to say. Okay. I'd like you to finish this one. This is one kind you have to do. Then we're going to do one kind where you have to multiply them. And then we're up to today's divide, and then we'll finish with one divide. So try this one. In a moment, I want you to get the answer. It's like, 6x squared minus 20 or something like that. Compare your answer with the kid next to you, and then we'll try a couple more problems, and then we're done. So just give me a couple more minutes of your attention. Much excitement. All quiet on the restroom front. I think it's the eastern front we have to worry about anyway. At least if you're in Europe. Okay, here we go. X squared and this minus x squared. Do you get that those are opposites and therefore they will cancel each other? Maybe I should just not skip too many steps here. X squared plus 3x plus 5. That parenthesis can drop. but this one can't. Negative x squared, negative 3x, and positive 5. And then, does everything cancel? X squared and negative x squared definitely cancel. 3x and negative 3x definitely cancel. And positive 5 and positive 5, they don't cancel. The answer was 10. Raise your hand if you had a 10. Okay, awesome. That's the add subtract kind. How about the multiply kind? Everybody just try this one. 2x times 7x to the third minus x. These sometimes get tricky for people to keep track of what the power is and everything. Just distribute that one out and check with the kid next to you, please. See if you guys get the same thing. Okay, if you haven't already, please check with the kid next to you. (14x to the fourth minus 2x squared). Raise your hand if you had it right. Okay, awesome. Now, what if this had like a triple times a double? I'm not even going to make you do it right now, but if they had something like this times something like this, that's a trinomial times a binomial. You would just distribute each piece to each piece. And you'd have 2, 4, 6 different answers. You'd put them all together. That's how you do the multiply kind. And then I really would rather focus on the divide kind. One last divide kind. What if I had x plus 4 here, x squared plus 3x minus 4 here. Try one last long divide. Let's see if you got this. So here's the first one. X. Because x times x makes x squared, and it worked. Yay. And then I just subtract it, and then it's gone. And then I drop something. And then I think, what do I put here then? And then I got to go, well, I guess if I put a 3 there, it would cancel off that 3. So I'd put a 3 right here, and then positive 3. And then I go 3 times the x is 3x. 3 times the 4 is 12. Wasn't expecting that, but it is 12, isn't it? Am I doing something wrong here? Tell me if I'm doing something wrong. And then opposite, opposite. Is that right? 3 times the x is 3x. 3 times the 4 is 12. So I think I did it right. Okay, and then these two cancel, and I just have negative 12 left. And then I got to put this negative 4. What the heck? Oh, I know what happened. I should have brought this negative 4 down. Did any of you remember to bring the negative 4 down with like the arrow? Okay, so some of you guys are smarter than the teacher on this one. I should have brought that minus 4 down. Oh, I see something else I did wrong. I'm sorry. I just messed this one up royally. Just give me a second. I'm not completely wrong, but I'm mostly wrong. Right here, I forgot to go this times this, plus 4x. Sorry. And then it's opposite, so this is negative and negative, and then it's negative x. Okay, did anybody have a negative x in the middle of your problem? Okay, good. You guys all beat me, because I screwed that up. All right, so now I'm bringing down this minus 4, and then this has to be a minus 1, because minus 1 times x makes minus x. Minus 1 times the 4 makes minus 4. Everything's matching up perfect, which is what we wanted. Nothing left for our remainder. X minus 1 and x plus 4. Raise your hand if you had it right. Cool. So sometimes we just do it where it won't work and you got a remainder of like 7. You just got to tell us what the remainder is. You know what I mean? So sometimes they aren't going to work, meaning there'll be a number left down here. That's called the remainder. All right, so let's get to the actual homework questions. And I'm not going to do this homework ticket thing. We're just going to get to the first homework question. Would you guys open up? They're big problems, so I'm going to make it so you can skip 1 or 2 of them. Open up the homework worksheet, and they're a little obscenely large. Parker, can you read me number 1, please? The big part goes underneath the root like this. Okay, I'll come back to you in a minute. Somebody ready just to read me the problem? Please, sir.
First one?
Yep.
Divide 2x cubed plus 7x squared minus 6x minus 8 by x plus 4.
To make sure I got that right. 2x cubed plus 7x squared minus 6x minus 8?
Correct.
By what?
X plus 4.
Thank you. Okay. Then I'm going to put what on the top? Well, I got to think something that would make it work out to be 2x to the third. So I need a 2. And then I'd need an x. That'd make 2x squared. Oh, 2x squared. Now when I multiply this times this, I know it worked because I get 2x to the third. Then you do this times this. I'm doing the first problem with you here. So 2x squared times 4 makes 8x squared. Now I do the opposite game. This is canceling, which is what I always need to happen. Otherwise, I'm not doing it right. But then there's usually something left. Yeah, these two together make negative 1x squared, or just negative x squared. And that tells me what to put here. I know whatever I put here has to be multiplied by x, and it has to be negative 1x squared at the end. So I could say negative 1x, negative 1x times x, negative 1x squared. Awesome, it's working. Negative 1 times the 4x, negative 1x times the 4, negative 4x. And I forgot to bring something down, minus 6x. You always need to have 2 terms to match up with the other 2 terms. Then we do the opposite game, and we have negative 2x. Always need to have 2 terms, Mr. Server. And then with finishing it off with, what number goes here?
-2.
Negative 2 is correct. Negative 2 times the x makes negative 2x. And negative 2 times the 4 makes negative 8, and everything worked out perfect. 0, 0, you know you did it right. Sometimes, though, we will have a remainder, so don't freak out if there's a remainder left. And the answer was that this times this was equal to that. I factored it. So it's a powerful way of factoring. There, I think you learned something. I know it's not easy, so if you get stuck and you want to come up, you saw me make a mistake. I don't make many mistakes in your class. I do in my honors pre-calc class because that's way harder, but even the math teacher made a mistake today. You can expect yourself to struggle here and there a little bit, but just come up and ask me, and I want to help you. All right, so how many problems are there in the worksheet? 6 is a little obscene. Let's cross off 5 and 6. If you do 4 of these things, I'd be good. If you want to do the others for practice, because you'd like botch a couple of them, feel free. That would be smart. Remember, tomorrow's review. Test is Wednesday. That's all I got for you for today.